I am so excited to be here at the Formula One exhibition here in Toronto. We're going to explore the science of Formula One, the science of winning. Come explore with me. So of course, F1 engines are ever-advancing masterpieces of engineering. Turbocharged hybrids with kinetic recovery systems that can squeeze up to 50% of the energy of their fuel and convert it into breathtaking forward motion. That's twice, if not over twice, the efficiency of your typical car. But there's way more science to Formula One than the engines. In order to reach those incredible speeds, researchers have made use of computational fluid dynamics. That's the computer modeling of airflow around the car, and boy, is there a lot of air moving around the car. In particular, the rear wing, forward wing, and floor of the car are made use of in order to create a down force. Now, like a wing on a plane, you want lift to go up. Well, you don't want cars to go up, you want them to stay on the road. So the down force adds extra force which presses down. Important because that increases the friction, the grip of the tires holding it on the road. And you want to do that because you're going to, well, maximize, or in this case, minimize the weight of the car. So you're going to make sure that you have as little mass as possible so that it's easy to accelerate or change direction. So you want a light car, you need that extra downforce to hold it down. And when it comes to making it light, well, that's where material science comes in. Carbon fiber composites. They're fibers that have been woven together in layers, and each layer or ply is then bonded together and arranged for strength. And it becomes a very light and durable structure. You can see it throughout the vehicle in over 80% of the surfaces. Epoxy resins are commonly used, or resins like polyester, vinyl ester, or thermoplastic resins are used to make that bonding and to make those fibers stick. You have to form them in a mold under precise temperature and pressure in order to get it right. It's incredible science. And of course, we use ceramic matrices when you want something that is fire retardant or heat resistant, wherever heat might be a problem on the vehicle. And if you really want durability, well, you switch to metal. We're talking magnesium and titanium as part of the structure as well. A great example of this is the monocoque. Originally a French word, refers to the inner structure of the car, an inner shell. It forms the cockpit in which the drivers sit, and it protects them so that if they get into a crash, it's durable, they don't get as hurt, and they're able to get out quickly. Another example of that is the halo. It is specially designed to withstand more than 2,200 times its own weight. We're talking 12,000 kilograms, about the weight of a school bus. And it's designed that way so that in the event of a collision, a crash, it deflects debris, even other cars, away from the driver's head. And the car itself absorbs that crash by crushing and falling apart. The drivers are literally clothed from head to toe in advanced materials. A helmet that is insulated and durable to protect, of course, the brain box, a suit that is flame retardant. In fact, it is certified to maintain a temperature of 41 degrees Celsius, while outside there may be a temperature of 600 to 900 degrees in the event of a fire. And not pictured here, but there is a support system that makes sure that their head and neck is held safe, the Hans head and neck support system. And each race is itself a test of endurance and, well, physical and emotional fitness. They have to sit in a cockpit that can reach 40 degrees Celsius, in fact, as much as 50 degrees on a hot day. Can you imagine? Drivers report losing anywhere between 2 to 4.5 kilograms, and most of that is sweat. They have to be in constant communication with their crew, making split-second decisions. Is it any wonder that their reaction times are reported to be the fastest in the world? Aerodynamics, material science, human biology, just how many formulae are there in Formula One? So much science, so little time. Race over and explore this exhibition before it's gone.